Yeah, once ready, please let me know. I can
Yes,
start.
sir. We'll live now.
Oh, okay. Thank you.
Good afternoon,
Hello,
everyone. Welcome to this exciting
Yes.
session on blockchain fundamentals, beginner's guide. We are honored to have with us Sri Vigneswaran R from TCS, a knowledgeable expert in blockchain technology. In today's session, Sir will introduce us to the foundational concepts of blockchain, demystify its working principle, and highlight its transformative potential across industries. This is a fantastic opportunity to gain a clear understanding of this game-changing technology. So I request all of the participants to make full use of this session, uh, and as it will help you in the later on stage for the grand finale. Let's give him a warm welcome as we begin this journey into the world of blockchain. Vigneswaran sir, over to you now.
Okay, thank you. Yeah, this is Vignesh. I'm working in TCS research wing. So we are working on blockchain. And let me quickly start. So for today's session, the agenda is something like I'll quickly give an
Hello मैम
introduction about the blockchain. And
मैम अभी
uh,
योगेश सर भी कह रहे थे मैंने ज्वाइन किया मेरे को मिला ही नहीं कोई
hello, am I audible? I'm getting
ओके मैम
some
मैं
other
एक बार
voice.
बात अभी कौन कौन है मैम मीटिंग में ओके मैम मैं अभी बात करता हूँ बाकी मैंने ग्रुप पे वही सेम लिंक भेजा है
I think you are on.
ठीक है
You
मैम
are
अभी
not
बात
on mute. Hello. Yeah, maybe I'll proceed. Okay. So the introduction about blockchain, and before getting more into blockchain, we will see the purpose database related use case and add some more features and threats, and how we will see how this can be mitigated or addressed by the use of blockchain and various building blocks of blockchain and the types. Then I'll take one particular blockchain named Hyperledger Fabric and give some information about it and explain a smart contract. And I'll show some demo video which I have used sometime back, which I recorded. And what are the challenges in the blockchain, so that we can take informed decision when to use blockchain, when not to use blockchain. So these kind of things. So this is the summary of thing I'm planning to cover here. You can go and explore more to get an in-depth understanding. So basically, blockchain is, we can think of it as functionally a database kind of thing. We are going to store data in blockchain. That is the purpose. However, it is something more than blockchain. More than database. Instead of a single party holding the database, now multiple parties come into picture. So it is a decentralized mechanism. It is not like a one database is mirrored into multiple, or a master slave kind of setup. It's not like that. It is peer to peer setup. You can assume that there are multiple database. They are connected and they take care of inserting reading from their instance. So it has its own autonomy. So that is the decentralized nature. And up and only. So here the data is unlike we insert update database records. Here the record once added is just added. We will append more records, just like our um, uh, bank statement. So even some amount is detected by mistake, there will be another record which says it is credited again. It's not like existing thing will be updated. So we will have records for everything, every action. So that is up and only cryptographically verifiable. So the records, whether it is tampered or not, that we can verify in a cryptographic manner, that we will see how. And it is highly available due to its multiple instance nature. Okay, so before going further into blockchain, let us consider some scenarios. Currently, assume that it is based on it is in database. It's using database. So this this scenario is about telecom call records maintenance. So when we call between different telecom providers, BSNL, Airtel, BSNL person calling Airtel. So this kind of thing, somewhere some switching is happening, and they maintain a record that okay, from this operator, another operator is being called or served by another operator. So later, based on their records, they will settle the amount. Okay, this much of your thing I have served, something like that. So now they independently maintain their own records. So what, see, these siloed copies, the problem with siloed copies is sometimes it leads to inconsistencies. This is what we heard from telecom operators. It is a practical problem. It leads to inconsistencies. So they do some reconciliation to match the entry, which is a time consuming process. Not only this use case, there are cross border payment kind of use case or cross bank payments kind of use case. So that places also there are siloed copies of data records maintained, and there is some mismatch and they have to do some reconciliation to settle down. So this takes efforts, time, and finally cost, and reduce user experience. So these are all the challenges with maintaining siloed copies. So now how we can make it improved by sharing a common database between them. This way we can reduce cost. We don't have to do reconciliation at once. A record goes means it is consistent across all the parties. So how we can achieve that? This is the question we are posing. How, and we will see how blockchain will help here. See, this is one scenario where we want improved efficiency through blockchain, or the challenges which we saw with the um, database. So another scenario, let us consider that every bank maintains their own KYC database where they maintain the record about their customers, and this is a recurring process. That means once in every few years they have to verify the KYC information. They collect the physical data or proofs and verify against the data in the ledger, and they confirm it. So this is a process which costs some money to bank. So for every user, something like 500 rupees or something like that is the cost for the bank. So consider every bank does that, and there are some overlaps between user information between the banks. For example, here XXX and YYY are present, are customers of both the banks. Assume that if one bank verifies the information and it can share with other bank, then the other bank maybe it can pay also a reduced amount, but the overall we are getting improved privacy and improved efficiency and cost reduction. This is one angle we can see. By sharing the data, by making the data transparent across multiple parties, we can achieve more efficiency. This is one such use case. Also, the same transparency can help in avoiding some frauds. So threat mitigation also it can be useful. For example, with some invoice data in a trade receivable discounting system, that is a system where people can get finance based on the invoice they got from some out of some big order, the manufacturing, something like that you can consider, and the invoice to be funded only once. Now in this scenario, if a person is using the same invoice in multiple financial institutions to get funding, then it's kind of fraud. Now the fraud happens because they don't have any common mechanism to share such data. Okay, the same invoice being funded by me, so don't fund anyone else, don't fund. That kind of information sharing is not there. So how we can enable that? Is that isn't it good if we have a common database maintained by all of us together, and where we can keep this information so that whenever somebody is requesting for funding, we can look into the database whether he already got fund from some other bank or not. So several frauds or several such use cases you can assume now. So this is the fundamental. Through transparency we can reduce some fraud. That is the basic thing. And here one more issue is, if banks trust each other, they are all trusted, okay, then okay, you host it, we all will read from your data, something like that we can simply say. Or if we have a trusted third party who hosts the database and we all share our data to the database, we can make use of it. But if we don't trust each other, I don't want all the data to be handled by one person, and we don't want to involve any third party also. So in such cases, how we can maintain a single source of truth or a transparent database in a peer-to-peer manner? How we can do that? So these are all some of the questions with or challenges with regular database. Another issue. So let us consider this database where organ transplantation requests are maintained. People who are suffering from diseases and they need some kind of transplantation of kidney or any other organs. Here the thing is, first come will be served first. So that, let us assume that that is the thing we want to maintain. So when somebody can in a database, if you consider, there is no evidence if somebody managed to hack the system and make a change. For example, they can make a change of existing name to somebody else, somebody else's data, or even they can insert a data record saying that somebody else has already registered even though they originally haven't did that. Okay, these kind of frauds can happen because the database is inherently not tamper evident. So how we can avoid such tamper evidence? So basically we can think of some basic mechanism like adding a digital signature as another field, or having digital signatures in a and hashes in a chained manner to solve that. These are all, finally we can see that as building blocks of blockchain. Together we will see how blockchain solves these kind of problems. Okay, so now we got some idea what are the issues with the existing databases and why do we really need blockchain, right? So issues with existing ledgers. So threat of data manipulation or tampering without evidence. So lack of audit readiness. So by looking into the database, we don't know whether any manipulation is done or not. So it is not audit ready. Inconsistencies between siloed copies of ledgers, that also we saw in some of the use cases. The data maintained by different parties, the proper synchronization mechanism is not there. They independently update the data. There is possibility of inconsistency and lack of transparency between different stakeholders. So people maintain records on their own, but once or if it is shared, there is a possibility of reducing inability or inefficiencies and identifying frauds. So currently it is not there. So we can say that at a high level, there is a lack of a way to maintain a single source of truth, a common database between multiple parties. So that's what blockchain is going to address. So the purpose of blockchain is to maintain a single source of truth, a common database between multiple mutually untrusting parties in the absence of a trusted third party. Because if there is a trusted third party, they can host the database, everyone can write to it and we can read it. And in a tamper evident and peer-to-peer manner we want to maintain to achieve process efficiency, reducing costs or mitigate risks. So these are all some of the purpose for having blockchain. So now I'm just quickly revisiting the first slide. So now we got it. Blockchain is a database. Yes, it is storing record. It is decentralized. Multiple parties will insert or maintain their own record. It is append only. We are adding records only. We are not updating any record. And cryptographical verifiable nature will come because of the digital signatures and things like that, and high availability. Already we saw multiple copies are there. So what are the building blocks? So building blocks are to achieve whatever properties just now we were discussing, right? Means the tamper evidence and things like that. So hashing. So hashing is something like we can see for any input in or arbitrary length, the hashing will help us to do a fingerprinting or digest of the input data. Whatever the size of the data, it will give a fixed length fingerprint or digest of the data, so that even some data we can't visually see the difference. There may be a L and 1, that kind of changes. even that kind of changes or even a bit of change is there in the input data, when we do a hashing, it will completely differ. The hashes completely differ, and that can be verified. So this way hashing helps to quickly check whether the data is intact or not. Now adding that with digital signatures. So digital signatures come into picture when somebody unauthorized person cannot make any changes to the data. If they make any changes, they cannot create the same digital signature, or the verification of the digital signature will fail. So here quickly, if we see, digital signatures uses two keys. One is a public key and one is a private key. Maybe for a crude analogy, I'm encrypting some information with my secret password, which others don't know, but other people can verify that information with my public data. For example, my email id, with that you can verify it. So that is how digital signatures work. To create, we need a secret key. So how it comes into picture here, for example, in the previous use cases, once some authority creates a digital signature on the record inserted in a database or anywhere, that signature is also kept in place. Then if somebody else, some hacker is even changing part of the data, later somebody want to verify whether the data is intact, they can check the digital, they can recompute the digital signature and see, verify the digital signature and see whether the data is intact or modified. So the tamper evidence will come based on the using the digital signature mechanism. And moving to hashing, we can see some demo here. I would anyway I'll share the presentation so that people can see the demo. So here the thing is, the demo consists of hashing, how hash works, how a simple block works, how a blockchain works. So whenever a data changes here, we can see the change in hash. So that is the idea. Maybe if time permits, I'll show the demo in the later part of the session. Another building block is Merkle tree. Merkle trees are used in Bitcoin. The transactions, we talked about multiple records. Let us assume that multiple records are there. We can frame the records in a order the records in a particular manner and create the hash. We saw the digest of them in a particular order, the tree fashion, and we get a root hash. So this root hash actually is a fingerprint of the entire transaction and their ordering. So that root hash can get into a block in the blockchain. So blockchain, for example, we can see that a block header consists of previous block's hash, the timestamp, transaction root which we computed this way, and a nonce. And this entire thing will be this hash of the entire block header is present in the next block. So this way the chaining is formed. So even if somebody is making a change in the transaction root of transaction of here, everything will be affected. So they have to actually modify the entire chain to achieve a successful attack without being identified. Otherwise, whatever changes they make, they can easily identify. So this is an efficient way to keep a fingerprint inside the block header. So now the next building block. So the first we saw the building block of hashes and digital signatures, which helped in avoiding tamper evidence. Now the smart contract is going to help us in getting the autonomy. Okay, I want to insert my data. I want to compute on my independently on my side. So that is what smart contract is going to enable. So we can consider smart contract as a function, or it's a set of rules or a simple rule which will be executed whenever a transaction or whenever we need to insert a record. For example, a KYC record. In our use cases, any record we want to insert, before inserting, everybody will independently execute the smart contract just to verify whether the records are inserted according to the rules which we all agreed upon. Okay, so business smart contract can be simple rules, or it can include a bigger business logic also, a set of functions which implement business logic. For example, a transfer, money transfer function. Let us assume that the data, the entire blockchain is about uh, maintaining the records of transaction between parties, like a bank transfer between different banks or something like that, we can assume. So here the inputs, we can see that the whose ledger, the sender, recipient, and the amount to be transferred. So these are all the basic um, um, things we can see, we can assume, right? We can expect these are all the things, right? Getting the balance, reducing from the sender, adding to the recipient, and setting, putting it back, right? These are all the business logic we are going to do. And the execution, so to some extent this smart contract is little bit specific to Hyperledger Fabric. Other smart contracts may look differently, but I'm putting here the smart contract about Hyperledger Fabric here. So what it happens is, then the whenever there is a insertion, the execution happens. It will do the execute, and every party will execute independently. Okay, currently the person initially has 100 rupees. Another person, the recipient, has 0. Now we are transferring 20. So what is the value according to you? So every party independently compute that, and then later they will check, verify. That is the consensus which I will talk later. But that is how we are going to maintain the single source of truth in a consistent manner across different parties in a peer-to-peer fashion. So that is what we are going to achieve with these kind of building blocks. So now everybody executed, and they said, okay, according to me, the new balance of A is 80, the new balance of B is 20, and every party is everybody endorsing that one after independently executing. So those things will be ordered. So this is the transaction. Together we can call this as a transaction. And this is multiple such transactions are ordered, broadcasted to different people. Now they will verify, yeah, whether this is still true, and they will commit it. So this is how they are achieving the synchronization of the data, or in a synchronized way they are appending their ledger because of this entire process. So yeah, consensus is implicit, whatever we saw in the previous slide. But in different blockchains, they are achieved in different ways. So this is a mechanism to arrive at a decision, or to reach agreement between multiple parties. So on the validity of transaction, whether everybody agree that this transaction is valid, or the sequence of state changes, the transactions are valid, so that at the end of the consensus, we all will get the same view of transaction history. Now we can see that how it is different from a database. In database we don't have such mechanisms, so independently, that is why the siloed copies uh, got some discrepancies, right? Now we are getting, due to these mechanisms, we are getting a synchronized view, and later we can see these are all added cost. That's why we need to see whether it is really needed, right? So yeah, it comes with the cost. And consensus mechanism, there are different ways: voting based consensus, lottery based consensus. I'm not getting into much deeper, but the purpose is clear, I hope. So now the types of blockchain. So now we saw various use cases. In some of the use cases, we it may be between some regulated entities, or permissioned setup. For example, if it is between banks, no other parties want to see, they can create a network of permissioned blockchains. There are some permissionless blockchains. For example, if you take a use case of cryptocurrencies, where there is no a central party to maintain the ledger. So then how will we know that a token or asset is transferred only once? A person is not committing fraud by sending the same token to multiple people. So that is where the blockchain is maintained by multiple parties in a permissionless manner. So that is, Bitcoin is a permissionless ledger where anyone can join the network by having the appropriate software, and they will get a copy of it. And everyone knows a particular asset, whenever it is moving between person A to B, everyone will get an information alert of it, and they maintain that record. So next time if somebody is trying to transfer the same asset to somebody else, they can catch it. Okay, according to the ledger, it is already spent. It is not with this person anymore. He is not the current owner. So that is how the single source of truth maintained by a community or the set of peers is helping us to identify or avoid frauds. So, okay, so now we know when permissionless or uh, more open thing is needed and more closed thing is needed. We will see a little bit more here. So, permissionless means no permission is required to join the network. Anyone can join, like Bitcoin, Ethereum. Here in the permission model, we need to have prior permission or the KYC kind of formalities need to be done. If it like use cases where only known parties are involved, so that kind of scenario permission will be better. So Hyperledger Fabric, Corda, and several other platforms are available for that. And in permissionless, the consensus mechanisms are usually slower, such as proof of work, proof of stake, because we don't know who are all the parties. We can't simply use voting also, because if we don't know who are all the parties, they can create arbitrarily many pseudo identities, and they can vote. Okay, I can create thousands of identities, fake identities, and I may vote more, right? This is an attack called Sybil attack. So these kind of things are possible in permissionless. So they go for something like proof of work, where regardless of the number of entities you simulate, you have to do some compute, or with that compute only you can arrive at some result. With that only you can prove whether you have done that work or not. So that kind of consensus mechanisms are used in permissionless. It is, yeah, slower and inefficient. In permission case, we have a better settings, right? We know each other, even though we don't trust completely, but at least the identities are known. We can say that who can vote or something like that. So this is here relatively faster consensus mechanisms are being used. And coming back to permissionless, it is more suitable for public hosting and use cases like cryptocurrencies, general voting kind of thing, crowdfunding, digital identities, that kind of use cases can be used. Here in permission, more suitable for enterprise use cases such as cross-border payments, goods tracking in shipping industry, or land titles. That kind of use cases can be used. And actually, permissionless is the complete decentralization. We can see to some extent, even though there are some unconscious centralization happens, like mighty people together may have more power to control the network and things like that. But theoretically, this is the permissionless is the more relatively more complete decentralization. Permission is a partial decentralization, because there must be some consortium or some governing body will be there in that. So we can decide which one to choose based on our use case, particular use case. And there is a hybrid blockchain model also. Here, a part of the information or the part of the transaction will be conducted within a closed network, like between banks or something like that. And evidence of that proof is submitted to a public blockchain. Okay, we conducted this transaction. The transaction hash of the important information is published in a Ethereum blockchain, something like that. They do. So that way they keep the good things of both world. So this way, limited anonymity between the network participants. In the closed permission place, anonymity is limited. People will be identified, but the information is shared in a public blockchain in a completely anonymous manner. So because one of the usefulness of blockchain is the anonymity also in a public network. And this leads to low cost when compared to public blockchains, as only few nodes are needed to verify in case of hybrid blockchain, because the permission side only a few nodes are needed. So these are all the three types we can say we can take appropriately. So now we will move to a particular blockchain. So now we saw that different use cases and how in different use cases blockchain can help, like the maintaining the single source of truth. So now we will see how we can use a particular platform to achieve that maintaining a single source of truth. Okay, so this is a permission blockchain. There are lots of pluggable components. We can change the consensus mechanisms and things like that. It uses efficient consensus. It has flexible membership services. Membership services are like ID. We need to join a network, means we need to have some identifier which everyone can understand. And it uses execute order validate paradigm. So here the transactions are executed and the results are endorsed. Okay, if I execute at the current state this transaction, this is the result I'm able to see, that kind of thing. Then they are ordered, then validated before committing. In some other blockchain paradigm, they first order the transaction, then in the particular order they execute the transactions and then validate and things like that. So this is a different paradigm in that sense. And it uses channels, means network of networks, but I'm not going to cover that much. And it has flexible endorsement policies. For example, endorsement is nothing but, okay, we talked about the transfer, right? In the transfer, I'm able to see after the transfer happens, A's account is 80 rupees and B's account is 20 rupees. And five people are actually executing the transaction. We can say that, okay, among five, if three of them are able to, that means the majority is able to see the same value, that is the value we are going to commit. That is one kind of endorsement policy we can assume. Another endorsement policy, maybe we can say that one of the person is the authority. So either two of them confirms or only this person confirms, we will take this guy as the we can give him high weightage. So these kind of flexible endorsement policies we can have. And there are some mechanisms through which, if we don't want to share every data with every participant, we want to keep something private in the same network, there we can use private data collections, off-chain data it's supporting. And there is a very good smart contract lifecycle management. Creation of smart contract means the business logic, right? The transfer function, everything will be part of it. And smart contract upgrade facility also there. So if you see here, these are all these are all two peer nodes from two organizations. Maybe assume that two organizations who are going to host the ledger. So L1, L1 or ledger, the same ledger maintained by different people. And this is a smart contract. A smart contract means they all come into a use case where a particular business logic will be there, right? If it is a money transfer, that money transfer logic is encoded here. Everybody is executing that smart contract, and accordingly only they will do the update of that. So now and this is the these people coming together, right? So they agree on some rules, who will be the certifying authority, what are the rules and regulations to join the channel and things like that. And this guy is the ordering person, means he will this person this entity will order the transactions into some sequence, so that and it will share with everyone, so that everyone will follow the same order while committing. That way we can maintain the data in a synchronous manner across ledgers. And these are all the applications and applications are submitting transactions, and the transaction will be executed by the smart contract. And then there is a sequence of steps which I will cover in the next slide, that will happen. So essentially, to relate that, if it is a KYC use case, different banks are submitting KYC data, and different banks, their corresponding peers are actually recording them as per the execution of smart contracts. And L1 are independently maintained single source of truth, we can say the common database maintained. That is the thing. Okay, so the hyper fabric transaction flow I'll cover in a very high level fashion. So this line is a client who want to submit a transaction. So they submit transaction to the multiple different endorsing peers. Peers means different parties who host the ledger, right? Two or three, whatever number of banks involved in that. They send the transaction to all or a subset which is needed, right? And they independently execute and give back the result. Okay, I executed, my results are the new transaction, the new values are bank balance of A is 80 rupees, balance of B is 20 rupees, something like that. So everybody execute independently their smart contract, their copy of that smart contract, and they against their copy of the ledger. Everybody has the ledger and smart contract, right? So they execute the smart contract against the ledger, because ledger has the current state. According to the current state, if I execute this one, what will be the result? So those result everybody is responding, and after collecting that responses, once we think that once the endorsement policy is met, okay, majority of endorsement I collected, they sending it to ordering service. So ordering service wait for some time. It collects information from different people like that, and together it sends create a block and broadcast the block to everybody, and everybody will just once again go through the transactions, just ensure that the transactions are still valid, and then they will decide whether to commit or not. So that is the high level thing. The committing happens at the end. I'm trying to give a high level. I think when you go back and read about it, you will get the better picture. So now we know, now we got the Hyperledger, how it looks like, what are the participants, what they maintain, these things we saw, and the transaction flow also we saw. Now we will see a smart contract. How a smart contract look like for doing a asset transfer, for example. This is a smart contract information taken from the links in the reference. It is from Hyperledger Fabric page only. So it's written in Go language. Okay. So we are, it is like we are importing the necessary things, and this is the one we need to highlight. So this API is provided by the SDK for the smart contract to interact with the smart contract to create or this to be a smart contract, so that it can communicate with the ledger for reading the state or writing it. So these kind of things, this API will help. So this is the convention to create a smart contract, and we will see what are the constituting or the asset, how a asset looks like. So here the assets properties, we can assume that the asset has a color, it has a value, it has some ID, ownership, size information. You can very well consider this as a KYC document also, where the name or any other address, date of birth, or any information need to be there. You can assume this as any type of information you want to maintain. Now this is a function in the smart contract for initializing the ledger. Initialization may be required or may not be required. In this case, for testing purposes, they are having some code to initialize the ledger so that it will be easier. So we saw the asset information just before, right? That data structure we are filling with some predefined values so that we can see how it works. Yeah, so that is the high level picture of this one. And these are all some of the APIs given by the Hyperledger Fabric for the smart contract writers. So we can use this to interact with the ledger. Put state means we are writing something into the ledger. We have correspondingly get state for reading from the ledger. These are all facilitated by the peer. So yeah, quickly for seeing, we are right now in the smart contract. Whatever we are writing is smart contract. We may interact with ledger for reading the current state, and then we do the operation and we need to write back the ledger, right? So for these purposes we need some APIs. That APIs are provided by the peer through that contract API things. So yeah, we are going to do that. So currently we are looking into the yes, that is the smart contract. So yeah, we initialized. Now we are updating the ledger, means we are creating a new asset. That For that we are providing a function. Means creating a new record. We can assume that create a new record of KYC data, something like that we can assume. So we are getting the information from the parties, what are the data we need to put, and we are filling, and once we create that, we are putting it into the ledger. So that is the updating ledger part. Similarly, we may need to read ledger, right? Whether it is as a transaction or KYC or any use case. So for this is a high level API which our smart contract, the smart contract writer is creating. In that, we are making use of the API provided by the SDK. So get state of a particular ID. We are getting for this ID. What is the asset information? We are getting it and we are written. So yeah, like a KYC data reading or anything like that. Similarly, we can delete asset. Okay, deletion means deletion is also another record. This asset will not be exist anymore. That kind of information. But if you go through the transaction logs in a ledger, we can see that at some point asset is created and some point asset is destroyed. It is not like while destroying or deleting, it's completely we are forgetting about the asset. It is still there in the records. So yeah, it will delete from a space where a index kind of thing, world state we call in Hyperledger Fabric. It is called world state. There, all the current state of the information is maintained. It is like our account balance is maintained, something like that. If we say the ledger entries are as our transaction logs, then the world state is our latest account balance for everyone, like that. So from that we can delete it. So, so demo is like a old video which I will run because I don't want to try it now. It may take a long time, and I don't have the currently I don't have the settings also. So here, the purpose of this demo is to show that currently there are 4 5 or a few commands we can quickly run to actually bring up the entire and check how it works. So that is made so easy. That's what I wanted to show. The objective of this is just to show that only. Maybe you need to go further to understand what is going on, but it becomes very easy, relatively easier to test any Hyperledger Fabric. So the prerequisite we need to install, and Fabric and Fabric samples are needed for the demo. So cloning of installation of these things and cloning of Fabric samples, Docker images and binary tools. So if we see, we need some prerequisite base software. On top of it, Fabric is the Hyperledger Fabric is built, and Hyperledger Fabric provides APIs. We saw that, right? Contract APIs to talk to the ledger and all. These are all the provided by through application SDK, and using that, an application can talk to or invoke transactions. So the APIs are for two ways. One is the smart contract to talk to the ledger, and another one is the application to talk to the smart contract. So the what the test we are going to see is just we will be bringing up the test network, and a channel will be created because the channel is needed for who are all the participants, that kind of maintenance. And once the channel is ready, now for the particular use case, we all the people have come together for a particular use case or purpose, right? If it is a KYC or asset transfer, whatever purpose, the corresponding chain code, we assume that it is already developed. They took combinedly developed some smart contract, and they agreed on, okay, this is the smart contract we all are going to run. Now they are deploying the smart contract in the network, and after that they will, as part of that, they will approve on all. Some sub steps will happen. Finally, after this step, everybody will be having their smart contract running and peer up, and they are ready to do the transactions. So submit transactions. So through this command, we are going to submit some transactions, like first call the initialization, and then we will do some query and things like that. Finally, through network SH down, we can shut down the network. So these are the scripts provided by the fabric itself. So we can simply use them to quickly test them. So the very first time, it takes a lot of time to install the dependencies, download the Docker images and things like that. But once everything is ready, the testing will be much faster. So before getting into the challenges, I'll quickly see the demo thing. Okay, so here at this point of time, the installation is completed. So quickly we'll see how much, yeah. So after completion of the thing, we will be start the testing script. So I have created a test script where I have copy pasted all the commands in the provided in the Hyperledger page. So basically the HLF testing is just a script which have all the shell script which has all the commands inside, so that we can quickly test. That is the purpose. I hope this is visible. Everyone is able to see the demo. If someone can confirm, that would be great.
Yes, sir.
Okay, thank you. So it is creating the necessary settings. Like in this setup, there are 3 peers, I hope, and so the corresponding Docker images will be created. So the entire setup is ready, and people have created the channel, and through the channel, these uh, organizations have joined also now, and now they are getting some more necessary Docker images. These are all yeah, recorded demo as we see. So we always let us connect it with the purpose. We are now doing a use case, and the use case is something like asset transfer, which multiple parties want to transfer and come together and transfer. That is why we needed this one. And in this, now we are seeing how we can use Hyperledger Fabric to achieve that, right? That is the uh, purpose we are seeing. And Hyperledger Fabric is actually setting up all the nodes, necessary nodes. And yeah, peer lifecycle chain code package. So chain code is getting packaged. So these are all the sub steps involved in the uh, sub steps involved in the deployment thing. Yeah, in the interest of time, let me quickly skip some of them, and we'll see. Okay, this step I can. Okay, so we have now a chain code installed and initialized. So these are all the initialized thing. Chain code invoke successful. We can see all the data which we saw in the initialization script. Asset owner, we can see asset 6, owner Christopher, something we are able to see now. We will continue that discussion, asset ownership. Previously the owner, so previously we can see that previously asset 6 owner was Michael, here we can see, and now the asset owner is Christopher. So these things are embedded in the script, but it is to show that at a high level you can quickly do these things with a few lines of code. You can achieve it, and later you can customize it to whatever use case you want. So that is what I wanted to show it as part of this demo. I think that is fine. In the interest of time, I'll go quickly. So now, okay, so far everything is good. It's now we understand that blockchain is something more than database, and what are the things we can achieve, when exactly to use, what kind of purpose it is solving, right? So uh, it comes with the cost. So there are some performance and scalability issues which we can it's evident, right? Because there are so many mechanisms like consensus, everything is there. It's not a simple insertion of things into database. So obviously these kind of challenges we can expect. Similarly, data archival, user privacy and transaction confidentiality, interoperability related challenges, query efficiency, because here it is not a RBBMS kind of manner it is stored. It is like a the storage is very primitive, like a key value store, or it's in a transaction records kind of thing. So it is not in a very efficiently stored. So obviously that kind of challenges will come. We can't do any complex queries and all. And now the transactions are signed with some digital signatures. So key management, we need to do key management, data migration, smart contract, which we saw. So smart contract is a program again. It can have vulnerabilities, bugs. So people can exploit that, and they did that in Ethereum and other places also, and managed to steal a lot of money. So these kind of things we need to take care. And auditability, compliance, privacy regulations, like GDPR may say that you cannot store certain information in a public way, or it should be in a later stage it should be removable, like a right to be forgotten. But in blockchain we can obviously see that that is not possible, right? So these kind of things are some of just where people are doing research, and several improvements are going on. But it is, we need to know that. So those are the technical challenges. We will quickly see the non-technical challenges. So apart from that, it is a bit difficult to onboard multiple parties, right? Because it requires multiple parties for the success of the blockchain use cases. If we are saying KYC, I am having it in a blockchain, but I am the only participant, there is no point, right? There should be multiple parties, then only sharing will be there. One person get used, the one data will help others also. But how will we bring multiple parties? They may have some challenges, right? They may think, what is the benefit for me by coming to that network? And sometimes people may need to join multiple networks also. And digital and physical world interaction, for example, we are telling that we maintain land registry records in blockchain. But if, unless this is the only way to transfer assets, if there is a different mechanism exists, then people may go ahead and spend the asset in a different way. And having blockchain may be just a theoretical paper information, but the actual asset is not, right? So we need to consider all these things. Similarly, uh, blockchain as such, it can't make everything correct. The data which is entered by ultimately a human, or whatever mechanism we use for data entry, that should be proper. Whatever get into should be proper data, so that blockchain can maintain the genuinity of the data. But if the data itself is wrong, we can't, blockchain can't help. Similarly, face-by-face adoption also, it's a bit difficult because of the rigid read-only nature. Append-only nature. It can't be edited, right? So some kind of challenges. So coming to the conclusion, when do we need blockchain? So how do we decide whether a blockchain is needed for a particular use case or not? For example, whether our whatever document we want to store, do we need, we can put it in an almirah or in a safe vault kind of thing. So it depends upon the cruciality or the need of the importance of the document, right? And we can see that almirah may be less costly, the space, but the safe means it's more costlier, and we need to put some keys to open. So all kind of difficulty come into picture instead of directly fetching from the almirah. So similarly, uh, depending upon the use case and the criticality of the data, we need to decide. So here is some way. Originally, it was given in this paper, and with the modification, we can find this modified version in the second paper. So do you need to store anything? First of all, if there is no storage, then no need of any blockchain or anything, right? That is the blockchain is a database kind of thing ultimately. Yes, we want to store something. Then are there multiple writers, multiple party involved, and they all want to write it? Then if no, there is no multiple writers, then is it a critical data which need to be tamper evident? Something like the organ donation we saw, right? even though the organ donation information may be maintained by a single party, but if there is a possibility of insider who can modify, or some attacker who can insert some data or edit some data so that somebody else get the benefit, but and denying the benefit of the actual person, that kind of cruciality we need to consider. If it is very crucial critical data which requires tamper evidence, then maybe we can still consider blockchain, but we will see what kind of blockchain we need. And if there are multiple writers, or all writers are known to each other, okay, everybody we need to write the data, but or they know each other. For example, we don't know, for in the use case of cryptocurrency, if we take, we don't know who are all the participants of the cryptocurrency thing, right? That kind of thing we can go ahead with permissionless blockchain, because we don't know in prior who are all the parties who will be writing. But if we know the parties who are going to write, then we can see whether all the parties are trusted. Yeah, we five people want to write into something, but if we trust each other, maybe we can collaborate on some platform, right? It's a trusted platform. We can collaborate because we don't worry whether somebody can tamper the data or something like that. It's a trusted setting. Then we can don't use blockchain. We can go for other kind of mechanism, but the parties are not trusted. So there are multiple parties, multiple writers, they don't know each other, and they are not trusted. Then um, sorry, they know each other but they are not trusted. Then we are coming to the final question: is public verifiability required? Publicly, that a record need to be verified. For example, even though the data or the transactions are happening between some banks, some information maybe need to be publicly disclosed. Let us assume that some use case that is needed, then maybe they can use public blockchain or a hybrid mechanism in which they will publish the proof of the transactions. If there is that is not needed, it's a completely private settings, then private permission blockchain can be uh, considered. So, and since we saw that there are lots of challenges with blockchain, we can consider some alternatives also. What are the alternatives? We can consider first, consider the centralized solution, whether we can design or design a solution for a particular use case in a centralized manner. Then we will see what are the issues which cannot be addressed in the centralized. Then let us see whether cloud-based solution can be considered if it is only high availability is needed, or database mirroring kind of thing is needed, just in case everybody want to have a copy, but client server or master slave setting is fine, I'm trusting the other parties. Or in some cases, only the ensuring data integrity or non-repudiation are the only objectives. We can use digital signatures also. In digital signatures, they can mention that uh, through digital signature they can achieve that the data is not tamper, or the tamper evidence we can achieve even with the database. We only for digital signature we don't need an entire blockchain, right? So that is what I am trying to convey. In certain scenarios, by using a digital signature itself, we can achieve the tamper evidence. And we saw in one cases, even though you have individual record wise digital signatures are there, you can't tamper the individual record, but somebody can insert a record or somebody can delete a record. That kind of thing, what can we do? Digital signature maybe simply don't is not sufficient. Then we can consider hash chain. So in that case, we are for every record we are creating a hash, and that hash will be added to the next record also, and all are digitally signed. So even one record is tampered, all the entire record will be affected because of the change in the hash. Because we are creating a hash chain. This is very close to blockchain. But if we don't need multiple parties, but only the evidence needed, we can consider this kind of hash chain also. And so, before concluding, the thing is, we just saw what is blockchain, the properties of it, and the various use cases. What is the requirement, the feature addition, threat mitigation, and how blockchain helps that, the purpose of the blockchain, and what are the building blocks which helps in achieving the purpose, and the different types of blockchain, public permission, and things like that. permissionless permission. Then we saw how Hyperledger Fabric, a particular blockchain, can be used to achieve that purpose, right? The maintenance of the single source of truth. And then the challenges we saw, various inefficiencies, something associated with the cost associated with blockchain. And we saw when to use blockchain and different alternatives also we just saw. So in the conclusion, every problem is not a blockchain problem. So we need to evaluate the suitability very thoroughly. Do we really need blockchain? Use blockchain only if it is the simplest possible solution for the particular use case. Yeah, these are all some of the references. Thank you. Yeah, that's all from my side.
Thank you, sir. Thank you so much for this amazing session. We wish all of the participants uh, best of luck for the grand finale. I hope this session helped you in a way so that you can uh, make your grand finale product more better. We can see some thumbs up for the participants as well.
Yeah, thank you all. Thank you.
Mm.
All the
Thank
best
you.
to everyone.
Yeah. Thank you, sir. Thank you, everyone.
Thank you then. Bye. Bye, everyone.